Mr. DeSevero is challenging us to find that angle. So let's accept his challenge and think about how might we measure that angle. Now, of course, there is a classic tool for measuring angles, and since this is a giant size sculpture, I came prepared with a giant size protractor, which is a great tool for measuring angles. So how are we going to use this protractor to measure that angle up there? I mean, I should just reach right up and put that up on that angle, right? Sadly, I'm not quite tall enough. So we need to use some math and the tool to help us get at that angle. So anybody have suggestions for how I might use this to measure that angle that I can't reach? Measure at the floor. I have no problem reaching at the floor, but how in the world is measuring the floor going to tell me anything about what's going on at that angle up there? Oh, use the circle? Which circle should I use?
I don't know what angle it is, but one of them up there.
Yeah, there's a big circle up there, so if we knew what fraction of the circle, that could help us. Any other suggestions for how measuring angles down here at the floor is going to help measure that angle way up in the air? Yeah?
Use these two angles and then subtract from them.
Yeah, so triangles are our friend, right? So triangle is one of the most fundamental geometric figures. This structure is in part made up of triangles, and we can use the power of what we know about triangles, its angles summed to 180 degrees, to measure that. Okay, so we're going to do that, and we can either, one of the great things about mathematics is there's always more than one way to do it. So there's another way we could do it, which I'll describe for you briefly, and that is to say we can use the fact that triangles are rigid. What do I mean by that? I mean that if we have any three lengths, for example, I've got these three sticks here. If the sticks form a triangle at all, there's only one triangle they can make, right? So if I want to try to make a triangle out of these, they've all got to connect, and there's only one way to do it, and I would get something that looks like this, and that's absolutely rigid. So actually just these three lengths would determine all the angles here. In this case of three equal lengths, the angles come out to 60 degrees. So another thing that I could do is I could use my measuring tape, and I could start measuring some distances here, and I could make a simple mathematical model of this sculpture. We don't have time to go into doing all the measurements right now, but I could measure the three distances around the base. That would give me this triangle. Now I want to model this pyramid. To model a pyramid, I need two other things. I need to know where the apex of the pyramid is here. I can do that just by eyeballing, saying, okay, it looks like I'm right under the apex. And then I could measure the distances here. That would tell me where this apex is. And then I could do this following thing. I could just lift this up into the air very carefully so as not to interfere with the artwork, and get that height. And that would allow me to make a mathematical model, a simple mathematical model of this sculpture, which with the aid of modern software, I could produce something that looked like this, a little drawing of the entire sculpture. So we can either see what I got with my model and then do the measurement, or go vice versa. Which would you like? Model first. Okay, so after doing all these measurements, plugging into this model, I predict an angle of 54 degrees at the top of this with all the different measurements that I just described. All right, so who would like to do the honors of measuring? Don't be shy. We need participation. That's what makes these things click. Maybe one of you guys, you want to measure an angle for me? Okay, do you know how to use a protractor?
Yeah.
Okay, cool. So I want you to measure that angle right there at the floor, okay? Yeah, the one right at the bottom there. So you got to put the numbers toward us. We want to measure this angle up here in the air. So we're going to put the bottom down here. That pointer is going to go right there. Yeah, exactly. Just like that. We're going to rest it against. There we go. And now can you read off that angle there?
It looks 72
72. Excellent. The guy is great with a protractor. Let's give him a hand. Okay, we got 72 degrees there. And anybody else want to measure the other angle? Takes 2 to triangle. All right, John, you're my guy. You want the pointer right on the line. Yeah, right. Yeah, put it right on on the beam. The pointer on the beam. There you go. All right. How much did you get? How much did you get?
71.
71. Okay, so 71, and so let's see. 180 minus 72 minus 71. 38. All right, 37, something like that. Okay, so that angle there is narrower perhaps than it looks, but triangles don't lie. Okay, excellent. So what could have gone wrong with my model? We have a discrepancy between my model and the measurements that we made, and we could think about where those discrepancies could be. Maybe it's too tricky to measure the height because I don't want to touch the sculpture, and the height of that apex is somewhere inside the sculpture. What else could be going on with the model? Yeah, right. I mean, maybe I used the software incorrectly. There's always human error. There's always a possibility. What else could be going on?
Well, maybe these aren't straight.
Yeah, well, so it's possible that Mr. De Silveira used curved steel beams. They're a little hard to find, but who knows? But there's also another possibility, which is we're modeling something as a triangle, and yet it's not quite clear. This is not an idealized line. This is not an idealized line. These are objects in 3 dimensions, and we don't even know if all of these lines exactly intersect in 3 dimensions in reality. So our angle sum might not be exactly 180, depending on whether those lines really intersect. So we have a simple model. They're fairly close to each other, and we've done our best to measure that angle in 2 different ways. Definitely, for sure, it's somewhere between the 37 degrees and the 54 degrees that we got from the model.